Okay, today we're going to be combining like terms using addition and subtraction, and this is going to be the basics of combining like terms. So, some of the things I want you guys to watch for when we combine like terms is one, you should be able to identify the like terms, arrange the terms so that the like terms are together, and then we're going to finally combine those like terms. So let's go ahead and do an example. What makes two terms similar or alike, I guess if I go back here, they need to have the same variables and the exact same exponents. So for example, if I say 5x and 4x, because we're not going to look at the coefficient or the number out in front, we're just looking at these variables. Okay? And if those variables are the exact same, then we can combine them to get 9x. And notice that their exponents also have to stay the exact same. For example, if I put a squared here or to the second power, then we couldn't combine them and we would just have to leave it as 5x and 4x squared. The way I like to think of it is by using the juice analogy. If this was 5 glasses of orange juice and this was 4 glasses of orange juice, the most efficient way to store that then would be get one pitcher and to be able to put 9 glasses of orange juice in that one pitcher. However, if we change this, so here I'll draw that second problem over here. We have 5 glasses of orange juice, but then we change the 4 instead of being an X, we change it to a Y. It'd be like having 5 glasses of orange juice and 4 glasses of milk. Well, if that were the case, if we wanted to consolidate those, we're not going to consolidate them into one pitcher. We're going to leave it as 5 glasses in one, 5 glasses of orange juice in one, and 4 glasses of milk in the other. Because if you combine the milk and the orange juice, then it's just gross and it doesn't make much sense. So um, keep in mind, in order to be able to combine these like terms, you have to have the exact same variables, and their variables must have the exact same exponent. So if we look at an example here, what we're asking ourselves is, out of this example, um, which ones have the same variables? If we look at 5x, 2x, and minus 3x, those all have the same variables. So we can combine them. Notice that I took the sign out in front of them. So in this one, there is no sign, but we do know it's positive. And so we have a 5x plus a 2x minus a 3x. So we're going to combine all those together. So again, if we're using orange juice analogy, you have 5 glasses of orange juice, 2 glasses of orange juice, and then negative 3 glasses of orange juice here. And then we should also be able to see that we can take this plus 1 and this plus 6. Those are glasses of milk. And it's okay to combine the milk with the milk. Okay? So when we combine the orange juice together, or our x values, you're going to take 5x's plus 2x's, which give us 7x's. And then we have to subtract 3x's, which gives us 4x. And if we go over here, we have 1 plus 6, which gives us 7. So now we're going to bring our 7 down. And our end result is 4x plus 7. This is kind of different for us. We've been used to getting exact answers like 22 or 11. But we're starting to dive more into the algebra. And the more algebraic side of it is understanding that it's okay to have an expression as our solution or our answer. That it's okay to have 4x plus 7 because there's nothing else we can combine. We cannot take this one step further to get 11x. That's wrong. Okay? Because again, that would be taking orange juice and milk and combine it together in one pitcher, which is just nasty. Okay, let's try example number 2. On this one, we start to have some more subtraction problems, so be careful of those because it does get a little bit tricky. And notice we also have 2 variables. So when we look at this, we're trying to find what can we combine that has the exact same variable in the same exponents. And so if you look at x, and you see here we have a minus 5x. Notice again I took the sign out in front. And then you have a minus 3y with the 2y. And then you finally have the minus 2. And so if we write these out, we're going to have the x minus 5x, negative 3y plus 2y, and then the minus 2. Now when we simplify x, that's another way of writing 1x. And 1x minus 5x is going to give us a negative 4x. Negative 3 plus 2 gives us negative 1y. And then, again, we just leave the negative 2. So now when we rewrite it, we should have negative 4x minus 1y, or just y, minus 2. Again, if you want to use the juice analogy, this would be equivalent to your orange juices, your apple juices, and your milk. And if we wanted to take this one step further, we would have one pitcher of milk, orange juice, and apple juice, and that just doesn't taste very good, and so it doesn't make sense to combine them. This equation, they're trying to play a little trick on us. They're trying to make it harder by throwing in these parentheses. But since everything's an addition or subtraction, we can just rewrite this without the parentheses. Because we have no multiplication or division, it's not, those parentheses aren't going to matter, and so it's just another way of writing it or grouping it. With that being said, now we can clearly start to see some things that can be combined. When I look at 2a, I'm asking myself, are there any other here with just a? And I find the 7a, and again, notice how I bring that sign that's out in front of it, so now I know that it's got to be 2a plus 7a. Then we look at our positive 10x. Any other x's? Yep, there's a 6x here. So we're going to have positive 10x plus 6x. And then finally, we have 4 with no variables. Do we have anything else without a variable? Yes, we have this minus 2. So we're going to have 4 minus 2. Now we can do some combining. 2a plus 7a equals 9a. 10x plus 6x equals 16x. And 4 minus 2 gives us 2. We bring them all together, 9a plus 16x plus 2. So notice that on all of these, when I'm combining the x's here, I'm not getting x to the third power. The x's stay themselves. Like, for example, this one that we just did, this 2a and 7a, that's the same as 2a's plus 7a's. 4, 5. How many a's altogether? Well, when we count out how many a's altogether, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 a's. So again, we're not changing the exponents. We're leaving it whatever it is. You might see one with exponents. Actually, I don't think you guys have that one. You might not have this one as well. If you don't, go ahead and write it. And I'm going to let you try the exponents on your own and bring those into class tomorrow. We'll go over them. But again, the parentheses are there just to confuse, so we can rewrite without the parentheses. Because this isn't a subtraction, we're not doing any multiplication or division. We're okay. We can just get rid of the parentheses. And now we're dealing with 1x, and we ask ourselves, are there any other x's? We have another plus 1x here, so we're going to have x plus x. We have a negative 6y. We have a negative 2y. So we're going to take that negative 6y minus 2y. And then finally, 9. One x plus 1x is 2x. Negative 6 minus 2 is negative 8y. And then finally 9 We put it all together. And we get negative, or 2x minus 8y plus 9. That's how we solve combining like terms. Again, good luck with this one. Try your best. Bring it into class tomorrow and we can see what, how you did. I hope that helps with the basics of combining like terms. Good luck.